My name is Arshad Hussain, group from group 323. Today our topic is steady state of linear system. The steady state of linear system refer the behavior of system as time approach of the system or to infinity. In the steady state, all the transient effect have died out. Learn only constant or periodic response. For linear system represent by where x xt is equal to axt plus 3x bracket t, where xt is the state vector and ut is the input and a is the system matrix and the b is the input matrix. The steady state can be understood as a follow. First, homozygous solution. Homogeneous solution, if xt is equal 0, the system steady state is determined slowly by the ingenious value of a. If all ingenious value of a have negative real part and is referred to referred to ost is infinity. Refer infinity. Indicating as a stable system that reached an equilibrium at the origin. Second is the partial solution. If there is a constant input ut is equal to u naught, we find the steady state solution by setting x is equal to o, leading to the equation x ss plus bx naught is equal to 0. A first response to periodic input for the sinusoidal input. If the system is stable, the steady state response will be sinusoid of the same frequency as the input, but possible with a different amplitude and phase due to the linear system properties. In control system, the steady state response can be does be analyzed using transfer function. For a transfer function, refer to hs is equal to ys upon ys us. The final value of theorem may help find to steady state output. Yss for a step input ut is equal to u naught by in evaluating. The reaction will be yss is equal to lm5 is react not. Now, this approach is the useful for intermine steady state value in system that can be module in Laplace determined. This may be illustrated by a spectacular module. The process of chemical reaction may be visualized as the flow of a liquid in the system closed. If the liquid may neither flow into nor emerges from the vessels, then the entire liquid will flow at a velocity determined by the trap aperture from the upper vessels to lower one. The state equilibrium in open module is the level will depend on the steady state flow rate. Example, on the extent to which the tap is opened, we see that the tap module we catalyze in closed system. The final extent of reaction does not depend on its rate. On the extent which to does not depend on its rate. On the extent to which the trap is open, there will eventually be set up of constant level of a liquid in lower vessels. In open system, not the rate but the extent of opening the tap is changed. New liquid level, a new steady state will be extended. In the summary of a steady state, the steady state behavior of a linear system is determined by the system internal dynamic or poles. The nature of the input and stability considered by the analyzing this factor in both the time of frequency and time and frequency domain, we gain in state to into the long term behavior and can design control to achieve specific steady state responses if necessary. Thank you.